started because we're 3 o'clock on the dot. So, welcome. My name is Kevin Casey. I am a senior solutions engineer with Yubikey. And today I'll be giving you kind of a rundown about what Yubikey is doing. Some people are very familiar with Yubikey and our Yubikeys. Some people it's brand new. And so kind of as a sampling so I know where to kind of steer the conversation, how many developers do we have in the room? Okay, so we've got a couple of developers. How many sysadmins do we have in the room? Okay, a couple of sysadmins. How many Gmail internet users do we have in the room? Probably almost everybody, right? Okay, so we'll get into that, and I'll stay not so deep onto the code, and we'll focus more on some of the usability and the capabilities that we're bringing into the market. So what we're focused on today is the Yubikey and the universal second factor authentication. It's really around a new trust model that's going to be designed to meet the usability requirements of the ever-growing presence of internet services. Everything is going internet-based, right? Today we do all of our online banking, we do all of our email, we rely heavily on the net. The challenge is how do we trust the net? When the net has lots of information about us and we're trusting that they're doing the appropriate things to protect that information. So we really focus around security and privacy for large organizations, but we've designed a product that is going to allow it to reach down into the hands of the masses. Because at the end of the day, we believe everybody has the right for privacy and security for their online transactions. Because at the end of the day, if security and privacy is eroded, ultimately it's liberty that's eroded. So we believe that wholeheartedly. And we build products to solve that problem in the industry today. Number one problem being passwords are broken. Who here doesn't believe that passwords are broken as a security mechanism? Is there anybody? That's good to hear. You'd be amazed on some big engagements. Occasionally I'll get the person that raises their hand in the back of the room and says, I got a good password. And then we go through the exercise of attacking their password and do all of that. So glad to see everybody here is kind of aware that that is broken. Of course, being a nerd, I can usually define every problem in the world to a Dilbert analogy. And this is one of my favorites. The key to your privacy and security in a disruptive world, this shift happens. We have to deal with that shift. And that's what we're here to talk about today, is how we can deal with that shift and provide you security and privacy in that online world. Yubikey is a small company. We are a company of 25 individuals spread out mostly between Sweden, where most of our development is done and where we originated, and the US team that is involved in most of the business operations and the architecting. So again, I'm a senior solutions engineer, so my role is helping large enterprises and entities integrate our solution into their environments and getting the word out to the masses. So again, we're a small team making big waves in the industry. And of course, we love security. We agree with Jennifer's statement from Facebook. They have embraced the Yubikey. We have 9 of the 11 largest cloud companies in the world have standardized on the Yubikey for all of their internal authentication security. Our mission this year is to get this capability and message out into the hands of the users and the enterprises. Because that is the largest attack surface out there today, is coming after the users. The cloud companies, they've solved the problem. They've recognized the need for these technologies. They've solved the problem to protect their user authentication mechanisms. Problem is how do we get that rolled out to their user base that are consuming their services? So as you see here, Facebook is one example. They've deployed the Yubikey globally across their environment. Every dev, every sysop, every user inside the Facebook enterprise has a Yubikey. Some of them don't realize they have a Yubikey. Sometimes it's very interesting when we run into users and see the nubby that we call it, or the nano device sitting in their machine, and we ask them, how do you like that Yubikey? And they'll give us a blank look, and what are you talking about? I ran into one in San Francisco as he got on the BART and asked him how he liked the key, and he's like, I thought this was a new feature with my MacBook. So he didn't even realize he was using the technology. That's our mission, is to get the word out, make people understand what's available. Why do they love the Yubikey? One, we believe it's got the best user experience. One touch and I'm in. One of our marketing mantras is we like to give the finger to passwords because passwords are broken. We allow a contact-based solution that allows you to touch and go. So unlike a second factor that requires an SMS or requires a battery-operated secure ID element that has to deal with power issues and synchronization issues or delay on getting the SMS, or worst case, you're in a non-covered area, deep in a data center, underground where you can't get cellular services, those mechanisms, again, can't solve the problem. They're broken just due to the nature of how they function. And we won't get into the breaches around SMS, because SMS is a breachable technology. If you talk to the intelligence services, they tell you how easy it is. There's some very scary technologies out there that 5 minutes with your smartphone, and I can own everything that goes in and out of your smartphone. Worse yet, I can turn it into a microphone. I can have it intercept SMS and send them to me. And I know these exist because I've deployed these in support of DoD operations overseas. It provides fast login to systems when speed is essential. Again, often people say, well, what do you mean by speed? We refer to that as friction. In an online world, the more systems we authenticate to, each time we authenticate, any delay is a friction point. So if you imagine in the world of Facebook and these large organizations and Google and Salesforce where their devs and sysadmins are working on potentially hundreds of systems a day, if you add a 30-second delay to each of their transactions while they wait on an SMS message to come in, and you multiply that by, say, 100 systems that they are connecting to at any given day, that's significant delay and interruption in their workflow. Of course, it's the best option when phone as the second form of authentication is not possible. Because again, if you're relying on SMS as your second factor and you can't get a cellular signal, you've just completely negated your second factor. Easy self-provisioning, we'll get into that. Durable and affordable. One of our founders had one of the keys swallowed by their German Shepherd. 3 days later, it pooped it out. We recovered it, cleaned it up. It still works. She still uses it to this day after it passed the German Shepherd test. We've had users reporting going diving with it, forgetting it was on them, go diving, no problem. This is a hardened injected, sealed unit to mil spec. The biggest problem we have with users is they actually break their USB ports because they get too rough with it, because they believe it's a button when it's actually just a contact. By touching the key, making contact with my finger is what releases the key. Supports proprietary solutions and protocols when necessary, because we believe the trust no one approach. Right? There's different systems out there, there's different solutions. We support a wide range, and we'll get into that in a minute, of the different authentication solutions that we support out of the box with little overhead. We've had large enterprises of 10,000 seats be able to implement our technology in 1 week. We provide all of the code to run some of the back-end authentication solutions via open source. We believe in giving back to the community because at the end of the day, we're a hardware manufacturer. We make a very secure authentication hardware solution. The software needs to be available to everyone because the only way we're going to make a difference and help solve this problem to the masses is to make it a low barrier to entry. You've got to make it easy for people to get access and be able to implement and use this technology without needing to be a security engineer. And that's been the failure of a lot of security technologies. They're written by engineers, for engineers, they're extremely complex, and they're extremely costly to get them rolled out into enterprises. So once they're in, people don't make a change because they remember the pain of what they went through to get there. We've streamlined that. So what does the authentication landscape look like today? Again, we talked about complexity and high cost against low security, high security and simplicity and low cost. Gartner has put us squarely up in the top vector, that we have an extremely high secure, simple and low cost solution available to the market today. So what is the Yubikey invention? We are a keyboard authenticator, no software, no drivers required. Our device shows up as a HID device when inserted into any computer. So it's an instant one-touch user authentication, no batteries, practically indestructible, and manufactured in the US and Sweden. We do not offshore our manufacturing because of the need to protect the secret that gets embedded onto the device. And by controlling that, although it's a little bit higher cost by manufacturing in the US and Sweden, it gives us that ability to assure our customers that that secret is protected. We're FIPS certified to 2267 under 140-2, and that happened as of October of this last year.
So I'm familiar with FIPS 140-2. What's the 2267?
2267 talks about the physical device and how it protects the secret. So FIPS 140-2 is the broad spectrum. The category of 2267 talks about how is the secret protected and is that secret accessible. So a little bit about our products and features. We have a couple of different products available. We have the Yubikey standard. Let me see if I can get my laser to work. The Yubikey standard supports OTP. HOTP is what we support today out of the box because not having a battery, we're not a time-based solution. We're a hash-based solution because, again, it's a solid component, no batteries in it. So we're not dealing with time. We're not dealing with the complexity of dealing with synchronization for a traditional TOTP. Hash OTP has no synchronization issues when you deal with HOTP. We have the Neo model, which supports multiple modes. It's a USB plus NFC capability in our Neos. It supports OTP via both the Yubikey and Oath. We also are PKI functionality. So we have a CCID smart card, shows up as a smart card when inserted, and on that smart card you can load PIV, Open PGP certificates, and it natively supports U2F out of the box. Then we also have the Nano form factor. And this one fits inside the USB port, does not extend beyond it. So this is for users that are, again, doing a large amount of authentication every day and are worried about breaking their USB port. So they can reset this, and it just sits on the side of the machine, and you just run your finger along to tap it every time you're requested to authenticate. The only difference between the Nano form factor and the standard is that it does not support NFC. There's not enough real estate on that tiny chip to be able to embed NFC capability. So if NFC is a requirement or a need, it kind of drives you to this form factor. Today, we've got over 2 million users deployed, 50,000 customers, and we're in 140 countries. These are some of our brag board of some of the customers that have rolled it out. One of our most recent that a lot of people became aware of Yubico and the Yubikey was the announcement in October of this last year by Google and Salesforce of native support for the Yubikey. Now, Google is very interesting because Google is pushing very heavily for the U2F standard. So what they rolled out was the U2F, which is the universal two-factor non-proprietary standardized solution for two-factor into the world. Salesforce, they roll out the HOTP solution. So they authenticate against our UBX cloud for all their users. But it was a big win for us because of what it did to make awareness in the market that these big players are moving forward with this technology. So doing U2F and what is two-factor the right way? Well, next-gen smart card technology for internet users is really where it's going to be focused around, of providing control to that user around their authentication. Development started in 2011, and again, we deployed into Google in 2012. It's been a very interesting ride as an engineer within this company because we are dealing with customer pool that I have never had to deal with in previous startups and technology companies. Big challenge with technologies and startups is actually pushing the technology and pushing the product out into the market to make the market aware. We've been amazed at the amount of pull coming from the industry. And one of the big drivers behind that was Google's announcement of their support for U2F, and then them enabling that U2F out to the world. So today, if you have a Gmail account and you use Chrome 39 or above, it's built in. It's native. You can easily go register, add your Yubikey, and you're off to the races. We launched it for Gmail October 2014 and initially deployed 500,000 devices based upon that. And again, we've got those in 100 different countries that popped up overnight. The day Google announced it, we released it on our fulfillment channel through Amazon. And within 2 days, we were the #1 new electronics product on Amazon. Amazon had never seen a product reach that height from that release date of 2 days. And that was driven mostly by the development and the security industry that were already kind of watching and aware of what we were doing. When Google announced it, it went off the charts of how much demand we started getting in. So in an example, and I'll do this live in a moment, but onto Google, once I've enabled my two-step verification on Google, I then register my key. Once I've registered my key, when I go to log into Google, it's going to prompt me to insert my security key, is what Google calls it, and tap and go. Because again, we have a solid state contact. So how we release the keys when requested by the authentication mechanism is a tap. So that's why we're giving the finger to the password.
It's just a momentary contact, any finger or any static?
Yes.
Okay.
So you can't wear gloves.
Biometric.
No, it's not biometric. So unlike what you saw in Black Hat, because Black Hat actually used a Yubikey in the movie. We were shocked when it showed up on the preview, when we saw the flash go across the screen on the preview of them having a Yubikey and inserting it. We all had to go stand in line so that we could see the movie to see what are they doing with the Yubikey. And in the movie, they portray it incorrectly. In the movie, they portray it as a biometric device that they're using to recover the bad guy's authentication to get his trail, and they portray it as a biometric device. It is not a biometric device. And we didn't get any product placement out of it either.
Will it work with capacitive fabric?
It can too. Yes, we do it via VM. So you can virtualize and do pass-through, but it kind of depends upon what is that virtualized front end, and can it handle the pass-through. In HOTP mode, it's easy. It's a string. We're just sending a string. Using it in other modes, such as any of the CCID, it really depends upon the infrastructure. VM supports the pass-through. Citrix, for example, on a VDI environment, has a problem of doing the pass-through on anything but just using the HOTP that's passing through a string.
It's always the same cryptographic hash that comes out in HOTP?
No, and I'll get into that.
You're going to go over the product.
I believe this one may not see me at the end, and we'll talk about that because this is focused on U2F, and we'll show the example of how we mint key pairs and how we issue those.
There's an input, and then there's a cryptographic hash output.
Correct.
And that has to be
Yep, and we generate and mint a key pair on the device, and the only thing that leaves that is the key pair and the verification of that key pair. So that secret is never exposed outside the device. So that mitigates that man in the middle or that compromised malware attack that's on the OS because it can't see the secret.
Does the key need to be left in throughout the session?
No, once you've authenticated, you can pull the key. You can have multiple keys inserted, and you just tap the appropriate key. So U2F, again, no drivers, client software, middleware. Native drivers built in. Today, again, Chrome 39 and above has it native. Mozilla is in development. Today we are number 7 on the Bugzilla voting list of needed solutions to be implemented. So 2 weeks ago, Mozilla development team out of Portland reached out to us, requested their key pack so that they could start developing to it. So we see Mozilla is going to be the next browser to integrate it natively within the browser. And then once Mozilla lands, it's just a matter of time before IE and Safari have to come to the table because the users are going to demand that, or they're going to lose browser share if they don't. So it's highly scalable to protect your privacy. It's a new encryption key for every service, and it's only stored to that specific service under U2F, which allows no association. So any service provider that's a relying party utilizing U2F has no awareness or any ability to track the use of that key across any other services, even within their own service. Because again, what they're storing is the hashed result of that minted key pair. And when you're authenticating and you register, you get that key pair registered into their database. When you authenticate the next time, it's validating, sending back the key handle. We validate the hash, approve that hash, and send it back with a yay or nay. So they have no way of associating. So I can use one Gmail account with multiple keys, or I could have multiple Gmail accounts using one key. They can't associate that I'm using the same key across those different services. Because again, there's no secret shared between the service providers, what we call the relying parties. It's a great user experience. I'm sorry?
Is there a limit to that?
No.
I mean, the number of keys?
No. We have no, I mean, surely there's a theoretical limit. We calculated out as about 256,000. So, technically there is a theoretical limit, but if you reach 256,000 services that you're using, for another $17, you can get another key. Great user experience was another critical component to us. Again, simplifying the need for security. So to register and authenticate, it's a simple touch of the button. Again, give the finger to the password. One U2F device to any number of services. That's the beauty of U2F. As the industry has agreed, we've got to allow users to not be carrying around what I call the janitor key ring, right? And for SAs in the room, you're probably intimately familiar with that. How many different authentication devices do you have between smart cards and tokens? And it's like, okay, which one do I go for now? Which system am I on? The need to simplify that so that a single key can serve all of those services is paramount. So how does the U2F protocol function? You have a registration function that the server sends the challenge. The device generates the key pair, so the generation is happening on the device. We wrap that in the private key. The public key is signed. The server receives and decrypts. The public key signature is verified, and then they store that. Then upon authentication, the server sends us the challenge plus that key wrapper. The device decrypts that wrapper, signs that hash, and then we send that back. So again, they're never getting that secret. They're never seeing that secret.
I have a question.
Yes, sir.
If you lose the key?
If you lose the key, there's a couple of ways that you deal with that. One, you can just go register another key and deprovision the previous one, because in the services, as I'll show you later when we go into, say, Gmail, I've got a list of my keys that have been registered. So if I lose my key, I can just go delete that key and register another key. For some services, such as challenge response, and if we're using CCID mode, where we've loaded certs on the key, we highly recommend that you make a backup of that key if it's for critical services. But again, lowering the cost of entry makes it pretty simple, because instead of $110, if you lose your secure ID token, you're talking $40 to replace the key.
But how do you get into your account to register the new key unless you're using?
They use a secondary
some
mechanism. You
other
still have a registered
method?
secondary mechanism, right? So in Gmail, we'll use Gmail as an example because we'll be able to show you the interface. In Gmail, you have a backup mechanism. Usually you have 2 or 3. Gmail provides you, okay, your
They're
primary
probably
second factor.
unsecure. They're not as secure as this.
Right, but you only need to log in long enough to re-register a new key in the event of a lost key. All right, so if I can't get in with my primary second factor, being a Yubikey, then Google's going to fail back to what I chose as my second option, which could be SMS or it could be a second email address. They're going to send a verification for me to gain access to my account. Once I've gained access to my account, I can go through and register a new key.
Right. My point
It
is
could
just
also be a
that.
pre-generated list of OTP.
Well,
Yeah, my
this is
point
U,
that
this
the
is
secondary
U2F.
should be as secure because while you're using the secure key, somebody's hacking on the insecure key until they go ahead and get into your account. So
Usually the
it
best.
should be as secure.
Usually the best way is to take an offline copy of the pre-generated lists, and then you have that encrypted somewhere else.
Correct, and they provide you that mechanism. Or you register 2 keys. So for example, Google bought 3 keys for every one of their users. So they bought 120,000 keys from us, and because we had to ask when we got the first time, we got sent out keys for all of their users on their order, and they came back with a duplicate order, and we had to whoa, did it not show up? What happened? Why are you? And then they informed us, so no, we're issuing 3. So we will issue one to the user, and we keep register 2 more, and we keep those in reserve for them. But again, that's a deployment choice of how you want to manage that based upon your risk assessment.
So
Yes, sir.
this has the problem that if you are kidnapped with the key, anybody can impersonate you.
Correct.
If you don't have time to disable the key, do you have any
But you have to have
biometrics?
your password too.
You still have to have the password or
Username,
PIN
password, and the
and the key. But if they get you, they can get all that out of you, right? Of course, if they get you, you've got bigger problems than worry about them logging into your Gmail account, right? Because there's really no tech.
hose method is extremely
Exactly. You took the words out of my mouth. At the end of the day, the rubber hose method is going to extract that out of you. The only way to deal with that is there's a different topic, and that's into the data protection. Because if you're taking mechanisms and if you have that high of a risk posture, you should be encrypting your data on top of dealing with your authentication mechanisms. And then that gives you a lot more options if you're undergoing the rubber hose attack.
plausible deniability.
Right. Yeah, or you use an unbreakable cipher that you can say anything you want, right? Because how are they going to verify it? So you deploy something like OTP, and then you can cover that. And that's a complete, I can go on for another hour or so on that topic. So Yubikey is a FIDO board member. We were the driving contributor behind the FIDO U2F. And when Google joined, that gave tremendous momentum. And of course, we've now got every major player has joined the FIDO initiative. The ones that are the slowest to adopt, not surprisingly, is Microsoft, although they took the chair of FIDO in January. And then, of course, the banking industry. But we're busily engaged with the banking industry as we speak to help them solve this problem. First review draft specs were published in February of 2014 for the FIDO U2F. It's a free open source. U2F references are available from both Google and Yubikey. So we believe in not the trust us, we've done it right. We believe in trust but verify. So to do that, we expose the code. It's all open source. You can see the implementation and the mechanism behind it so that you can validate it. Because the trust us model has been broken. If you can't verify, you should not trust. So the FIDO Ready Solutions, as of November 2014, there were 3 chip vendors making the chips for this, NXP, Infineon, and ST. We use both NXP and Infineon. There's 4 authenticators that have it native to their environment. We have 7 hosted providers that are now native, and 2 large relying parties that are standing up relying parties out onto the net. But again, the beauty of this open source solution is you don't have to trust these relying parties. You can go download the UBX code right from our repository and stand up your own relying party via Ubuntu in about 10 minutes. We provide a complete ISO working image for VM, allows you to take the image, load up, and within 10 minutes you can have your own UBX cloud for being your own relying party. So, driverless smart card redesign for the modern consumer web. That's what we're driving to. Again, I apologize to the non-developers. We won't spend too much time on these slides because now we start getting a little bit deep in the woods, but there are a couple of developers in the room. So really what it comes down to is we have two sides of this negotiation. You have the relying parties being the service providers. Those are the Googles, the Yahoos, the banks, those that are going to build and store that minted key pair when you authenticate via U2F to their service. The user side is broken into two components. You have the U2F authenticator, which is based on the hardware itself. Like I said, we mint the keys on the hardware. And then you have the browser that's aware of how to natively handle that. Because without native awareness, we do have organizations that have rolled it out, but without native browser awareness, they have to write that interface of how to communicate to the client, how to communicate to the USB and the CCID to be able to pull and mint these keys. When it's native to the browser, none of that is required. It makes it seamless for those users.
Just a built-in supplicate.
Correct. And because we do everything via USB HID, it's just keyboard strings. As far as that browser or that service is concerned. So today, it's USB. We're working on a Wi-Fi, a Bluetooth, and NFC is there today. We do have NFC, so if you use things like LastPass and have an Android, works today. Unfortunately, there's some manufacturers that are slow to adopt. iOS is probably the other problem. And Apple, like Microsoft, oftentimes tends to want to do it their way. So they have not opened up the NFC out to the dev world to look at their NFC implementation because they're really focusing on trying to do a proprietary LastPass approach to that. We see that the market is going to force their hand on that. So just stay tuned on that one because we're seeing the market have input on that. The way we're going to get around iOS is via the Bluetooth.
So what specification is that Bluetooth Smart?
That's still being defined. So that's in development as we speak. So our architects are working on how we're going to pass that Bluetooth because iOS also has some weird nuances on how they interface with Bluetooth, having access to the OS. Because they treat all Bluetooth as periphery devices when we need to actually be able to mint that key and pass that to that auth session and allow them to pass that auth session through. Yes, sir?
Have you guys considered marketing to like state-issued IDs, like your driver's license?
Yeah, in Europe we're already getting penetration there. But we're looking, they're actually coming to us and wanting to get away from the smart card and actually issue out these to their users. We're also getting interest from some U.S. Government departments for the same thing. They're trying to get away from the use of smart cards because of the complexity. Because the problem with smart cards is it's both complex for the user and complex for the enterprise that's trying to deploy them, right? You've got to deal with the readers, you've got to deal with the drivers. Even though smart card reader is native into Windows 7 and above, you still have a big problem on OS X. It doesn't have native support.
So that would be through the NFC channel?
Yes.
It also requires a smart card reader, which is another form of hardware that may not
Correct.
be available.
And has to have drivers and has to have overhead. We've even got a large printer manufacturer that's ripping out all of their smart card for their enterprise printing solutions and is moving forward with the Yubikey because they can now embed, verify that user identity secret for all their enterprise secure printing solutions. So we're seeing more interesting things come to the table, some that we had not envisioned. We got contacted by a group out of Europe that's looking at our MyFair capability because our NFC also supports native MyFair. And they're looking at ignition systems of how to combine that you have to have a Yubikey to actually enable your ignition on your vehicle. So it's the user community that's starting to come up with some of these very unique ideas on some very cool ways of implementing this technology.
What's your failure rate with your keys versus, say, smart cards?
We've had a 0.2% failure rate because, again, it's a resin-injected hardened device to mil spec. Like I said, our number one issue was USB ports breaking, especially on the small tablet, the ultra lightweight that have very little reinforcement around the USB. And I said you have users that tap on the device and break their USB. So we've had an extremely low failure rate. Our reoccurring comes from users wanting new capabilities. So we've had very little failure. Where we get is people wanting the next capability. They got a Yubikey 2 years ago that just supported HOTP and maybe static password, and now they want the U2F. And so we see most of our churn in product coming from users wanting the newest functionality, not from failure. So under the U2F concept is based, again, around registration and authentication. User binds the U2F device to their account. Server gets that device certificate. Server stores that public key and the key handle for that user. This is just kind of the breakdown of what we showed you graphically. On the authentication, the normal username and password process, although that can be changed to PINs. We've seen organizations roll out and doing away with the username and requesting a PIN because it's easy for users to remember a 4-digit PIN. But but that again, that's an implementation choice. User already has a registered U2F device to log in, then the server gets signed the blob and compares it to that public key and gets a go or no go. Now it also, one thing, well, I'll show it here in a moment, you can also tie that to an attestation key that's baked into our devices. Because some organizations are wanting to ensure that they restrict it to trusted hardware manufacturers. Because you're going to see, we're already starting to see organizations out of China starting to dump U2F devices after the FIDO announcement last year, started manufacturing and started dumping U2F devices out onto the market for $2 and $3 a device. Problem is they're proprietary. Nobody has seen how do they protect the secret. What are they doing? How are they minting this key handle? So at the end of the day, the U2F standard allows for you to call upon that attestation certificate and restrict it to known trusted manufacturers. We always hope that Yubikey is at the top of the list, but at the end of the day, there's going to be more players entering into this field. But it puts the control back into the organization that's standing up these services of what keys are they going to trust from what manufacturer. So again, for the developers, this makes sense. For non-developers, this looks like a bunch of lines and garbage on the screen. But this shows you how that process flow works. Starting with that relying party that gets an app ID and a challenge, checks that app ID from the browser. So you can actually tie this to specific apps within the browser. Then you get the app ID, you get the challenge, origin, channel ID, etc. Gets sent to generate the public, private, and that key handle. So we get the public key, the handle, the attestation cert, and the signature gets sent back to that relying party. That's what they're storing. And again, they can choose how they want to act against that attestation key to determine do they want to restrict this to trusted devices. And then authentication is successful. If you write Java, here's how simple it is to write that functionality into Java. So again, we believe in keeping it very streamlined and very simple, because that's what's going to get the widest adoption, is you've got to make it simple to implement. So how does the USB HID register? So we have, again, a challenge parameter and application parameter. This gives you the breakdown of what the payload is looking like. And I won't spend a whole lot of time, except the developers have questions around this. Under authentication, again, now that we've registered and we've got that key handle stored, now all we're sending back when the user goes to authenticate is the handle, the app ID, and the challenge is being generated from the relying party via that service. So we get that handle, we get the app ID, the challenge, the origin, so we can even restrict it down to what services, where do they originate from, so you can stop a lot of the attacks that are the phishing attacks, the redirecting, because you can tie this to a specific origin and channel ID. Once that comes in, I apologize, our screen is cutting off. Again, we verify against that private, we verify that hash, all we're sending back is a counter or signature, and then the AC counter against that. So again, the relying party does not have access to that secret, which is why that one key can be used across any number of services that are U2F enabled.
Is there any way to revoke keys below a certain counter?
Below a certain counter. Yes, you can bake that into the functionality, because if you're a relying party, the danger there is that if they are using that key on other services, the real thing you want to look for is does it meet your previous counter? Is it above your previous counter? Because if they're using that key for another service, the counter is going to increment. But if someone has copied your key and tries to do a replay, the counter is going to be the same or lower. So that's where you'd really want to focus it. But if you got too aggressive on saying it has to be within this range on the counter increase, you could run into a problem if they're using that key for a lot of other services. But you could say, no, we're going to, if I'm a bank, for example, and I want to issue you a key, I could restrict it that you only use this with my service. If you use it with another service, I'm going to disable it. Those are deployment choices that have nothing to do with how you can implement the U2F. You can be very strict. We're hoping most organizations will realize the value to allow their users to bring their own key, because that's really what this kind of brings to the table, is allowing organizations to not only issue out keys, but also allow organizations to say, if you've already got a Yubikey, you can register with our service and still maintain the same level of security. But again, that's an organization and a deployment choice. So here is what the JavaScript looks like for authenticating, for signing. Again, very simple. Everyone read? And again, if you want all of this, I can provide this. It's all freely available on our website, on our forums, and on our GitHub for anyone to gain access to. So again, on the authentication, we see that we have the control byte. We have the challenge parameters at a 32-bit load. We have the application, the key handle, and then we have the user presence. It's the tap, so we can verify user presence. That eliminates replay man in the middle because you have to have user presence with the key. A user has to tap to have verify possession. Yes, sir.
What's a key handle?
Key handle is what we meant. So we take that, if you'll remember in the previous slide, key handle is a combination of a blob, then the public and private certificate, and that generates a key handle. That's why we're never allowing that relying party to see that private secret. What they're getting is a generated key handle, that they're storing that key handle that then we hash against that. So that because the purpose was many keys to allow authentication of public-private that's unique for every relying party. It's generated during that U2F registration, so you have a unique value on generation that no other service shares. The public key is sent to the relying party only during the registration. The key handle can be used to derive the private key. That allows us that unlimited number of relying parties on a single small device because all we're minting and all they're having is the key handle. And then, of course, it's hard-coded to the elliptic curve. And, of course, we use NIST P256 curve standard for minting that. It's a device, is a unique symmetric secret. We unwrap and derive per that elliptic curve is how we get the key handle. And that's a unique randomly generated key for every device. So every one is unique that goes out. And we derive that private key using the HMAC SHA 256. I know we're getting real nerdy on here, but so the developers, they probably love it. Those that are not, just bear with us for a moment. So our U2F key handle. So you asked what the key handle is. Here's a graphic describing the key handle. It's a nonce plus the MAC and encrypted, so the device can derive that elliptic curve private key from the nonce and the symmetric device secret that's loaded on the device. And then the MAC detects invalid key handle or any malicious relying party because they have to have the validation of that minted key on registration. So the attestation key is, again, unique per batch. So we have organizations that derive and create their own attestation key that we then embed on manufacturer, and that links that device attestation certificate and allows you to sign those U2F registration blobs. And an organization can choose to have an organization unique attestation key loaded onto it. So you could restrict, again, if you were a bank, Bank of America or Chase, and you wanted to issue keys, you could have a unique attestation that's unique to your organization, so that you could verify that it has to be one of the keys that we at Bank of America issued out. We won't take any other keys. But you could still use that same key to then go register with other services.
Those keys aren't preloaded, or are they preloaded?
Those are. The attestation are preloaded. They have to be because they have to be baked and burned into silicone. Yes, sir.
What happens if, like, I'm working for Bank of America in that instance, and then I fire or leave, and I'm using that key for other services, and Bank of America requires the return of that key?
Then you have a challenge, right? Because you either have to get a new key registered with all those services. Usually, what they're not looking for the key back, but again, we can't speak for everybody and their security policy. Okay. The easiest thing for them is they just go revoke your key because they're not worried about getting this. To a large organization, they get this down pretty cheap. And so they're not worried about trying to get this back as they would be with a lot of others, high-cost tokens. Usually they just go revoke your key because they don't care about getting the device back because it's a low-cost device.
What about lost keys?
Lost keys, you have a couple of options, right? You have to register a new key with those services. That's kind of what we talked about a moment ago. Right? If I lost my key and if I don't have multiple keys registered, I have to use a secondary mechanism of recovering access to my account. Once I've got access reestablished, I can then re-enroll a new key.
And that depends on the provider of that service.
Correct. Yes. Someone had.
Do the attestation beforehand. Or
The attestation is done at the time of manufacture.
so you can only do that for one company,
Well, unless a company specifies that they want a unique for them, every device by default comes out with a unique randomly generated attestation. But we do allow for a custom attestation because we do have organizations say we want to put an attestation cert that just identifies our organization, and we do that on manufacturer at that organization's request. If not, if they're just buying it in bulk via one of our fulfillment, or they just want to call up and order several trays, each one has a unique attestation key.
Is there a minimum order that you would probably?
To do attestation, it's not a minimum order, but it's economies of scale. There's a minimum fee. So if you want one device with one unique, it's still $500 minimum to get that unique attestation. So if you want to pay the $500, we'll put a unique attestation key on the device. That you generate, because again, they already have a unique one. If you don't specify and you want a custom attestation, everyone has a unique attestation coming out of manufacturing anyway. So you could build your system to read and rely on just your attestation key. So if you wanted a private service or you had a private infrastructure, you could restrict it to only your attestation key because it's already unique unless you specify that you want to load one. And usually what we see there is an organization wants one attestation key across all their devices so that they can use that individual attestation key as an identifying mechanism that it is a, say, Bank of America
They would
device.
probably have enough orders so that they would have extras in
Correct.
storage.
Or every time they make a manufacturing run, we just put that same attestation key. Because like I said, that's usually the reverse model. They don't want a unique one on every device. They want the same attestation key on a large number of devices. So what if you want to support U2F? So again, on the server browser, it's a JavaScript API that sends the key handle in HTML and JavaScript to the browser. On the server side, you have to implement the registration flow, which is when you have to decide how you want to handle attestation certificates, which we just talked about. Then you need to be able to verify the registration response, meaning you have to store that data, those key handles somewhere. But usually that's just an extension to an existing database. Most organizations are just extending their existing author database and just storing that key handle associated to that user in their existing authentication system so that they can store that public key and the key handle associated to that user account. Now, it doesn't mean they can't stand up a new infrastructure. We've had some that have just deployed our UBX internal and use that for all their U2F. So on the server side, when you implement the login flow, you have to be able to check the username and password to look up that key handle against that database, verify the authentication response coming from that hash that's going back to the Yubikey so that you can look at the origin, the signature, and the counter against that. And then the relying party just checks your account. So again, our idea is we publish the host and server libraries in common languages. This is what we support today. Again, all available out on our forums and via GitHub. It's all open source. So some of the references around this, I won't read through all of these. This is where you can go find the details. Again, this is a standards-based solution, so you can pull. I'm waiting. I see some cameras coming out, so I'm waiting for people to take the pictures of the references.
Is this not available on the GitHub?
This is all available on both our forums, our GitHub, and our webpage.
Those reference links?
Yep. Any questions at this point? And then I'll launch you to a demo. Yes, sir.
Do you guys have any other competitors that are also low-cost devices?
Probably the number one competitor that has popped up recently is Knock Knock. Knock Knock. Against a Chinese manufactured device flooding into the market. So we don't know the strength of how they protect their attestation and how they're generating and protecting that private secret. But they're the newest player to arrive on the scene as of last year. And we've seen them hitting on Amazon dirt cheap, like a lot of things out of China. $2 a key, but buyer beware. Yes, sir.
So I think it's probably I already know the answer to this, but for the new U2F keys, are you able to upgrade like the Neo keys at all? Or?
Today, no. And there's been a lot of debate about that, and it wasn't really our decision. Previously, we were standardized on NXP. And we used to release the firmware SDKs out to the market and out to the dev world so that they could update firmware, have access and write to that. NXP squashed that under their license agreement, no longer allowing that. So for any developer that wants to be able to access that firmware and get to that secret, you have to register with NXP. My understanding is they have a cost. I think it's $25,000 to be a registered firmware developer to get access to their library. With that said, We've deployed Infineon chips into our newest ones. Now the debate is internal to the company of whether or not we're going to allow that, because the problem is when you start allowing access to that secret and writing to that secret, now you start entering into challenges around organizations or individuals that may screw up the security and control of that secret. And then if that secret is exposed because they misprogrammed that device, ultimately Yubikey would get the blame in the market, right? If someone went in and changed that firmware load and changed the function on the key handle generation and their environment gets breached, what's going to hit the press is, well, I was using a Yubikey and I still got breached. Doesn't matter that we say, well, yeah, but they accessed the firmware, they changed the key handle generation. None of that's ever heard, right? What's heard is we were using it and it still got breached. So that's the debate going on internally right now, is whether we're going to open that up.
How evident are the Yubikeys?
I'm sorry?
How physically tamper evident are the Yubikeys?
How physically, I still didn't hear that.
Tamper evidence.
Oh, it's a solid state device that's been injected molded. So if you try and break into the device, you'd have to do, there is one way to gain access to that chip, but it requires a very specific acid washing process to be able to expose that chip without damaging that chip, because you can't crack the device. It's an injected molded using a specialized hardened resin, which is why it can go underwater, why it survived the German Shepherd test, is because it's hard to tamper with it, because there's really nothing that that's.
But if somebody were to make a malicious fake, for example.
Oh, the attestation key that's baked in is what allows you to verify who is this really a Yubikey.
Right. But I mean, crazy scenario.
Sure.
Is, somebody, instead of having it act as a Yubikey, has it act as a malicious payload.
Right. So if you dump one out there and modify it, put in a malicious payload so that when they insert it,
It does something nasty to the machine.
right. Again, this is a one-way. So the hardware we use, the attestation and firmware is a one-way load, so that you cannot write back to this device.
What about voltages hitting the taps on the USB side? And
So far
magnetic fields?
we've run it up to 440 volts and haven't seen. Now again, can you fry it? Sure. If you make the right pin contact, as with any electronic device, yeah, I
Use
can.
that instead of the pickle tonight.
Yeah, yeah, exactly. You run that much amperage and voltage through it. I mean, it's a chip with plastic. Can I arc this out? Sure, I can arc it out.
So 400 volts.
We run 400 clean, but again, not arc through it. You arc through it, it's gold contacts and a gold contact. Can I arc it and melt it and ignite it? Sure. Again, stick it out on the pickle machine tonight, and I'll give a cheap one if you want to see it, but you can fry it, just like with anything else. If I throw it in the fireplace, yeah, I can melt it. I can burn it. All of those things, we can't. It's not a technology problem.
Static.
No static, because it's again, there's no active component. So we've handled static loads, and it's been fully tested.
What happens in the case of, say, man-in-the-middle attacks or keyboard loggers on the machine that the Yubikey is plugged into?
Well, so there's a couple of things there. One,
You did
good fun.
mention it was registered as a human interface device, right?
That's how it shows up on the device, so that there's no driver required because it shows up as a HID device. But that's not a man-in-the-middle issue because it shows up as a HID. A lot of that's dependent upon the authentication protocol. So for example, if we're talking HOTP, by the design, a man in the middle is going to grab the last hash, right? The next hash is going to be unique that has to be verified against that original key pair hash. If you're talking U2F, the relying party is only going to verify via that public key and that key handle, so a man in the middle is going to have a challenge because he can't mint a new key and verify against that key handle, because first he has to register. So there's no easy vector for man in the middle or malware on the machine because they can't get to that secret.
Okay.
And each time you hit that relying party, you're going to get a new hash because it's based upon a nonce, an app ID, and the characteristics that we mentioned. So each time you're getting a unique hash coming back that's then wrapped in that public key.
So malware sitting on the machine will be able to see that hash.
It'll see it go by. It can grab it.
Go by,
But can it generate a new one? No, because it can't get to that secret and know what that the original minted
but
key pair.
I'm seeing a hash coming from, like, say I'm in the middle.
Right.
I'm seeing a hash coming from the machine. I can't open up a new authentication session
No.
and throw that hash.
No.
Because there's some other variables that were part of the input that created that hash.
Okay.
So
So unless you had those,
you have to be able to generate a new one and don't have all those variables correct, then it doesn't work.
Exactly. Yeah, I'm sorry. Yes, sir.
So what's your pricing structure for individuals? So I'm not a developer. I'm just
Yep.
a person that's
So
interested.
it runs, well, today's your lucky day, because here in a moment I'm going to be giving out a bunch of keys. But the going price is for a basic U2F only. So we have a couple of models that you'll remember early on. A U2F only device goes for about 17 bucks on Amazon. The Neo device that is also NFC, so the fully loaded device runs, I believe it's listed at 52 on Amazon. So again, none of ours is over $100. 60 is about the top of the tier. 65, I think, is the newest. The Nano is 52. So again, the barrier, we didn't want to make price a barrier to entry, because that's the intent, is to get it out to users and get it out to the masses, so you can't have a high price entry point.
So if we do want to buy one, you just get it off a reseller like Amazon.
Go to Amazon. You can go right to our OS commerce site. So if you go to our webpage, we also have a e-commerce site that you can buy it straight from us, but you can also just go right to Amazon and buy it.
Okay.
Any other questions before I jump into a quick demo? Yes, sir.
Well, it's kind of related to that other person that just spoke about the possibility of somebody exchanging your key. Like say you put it down and they put another one in the place of it that had some payload because it's an HID way to defend against that, I'm thinking. Or
Well, we can't stop that.
NFC
That has nothing to do with
safer.
us. If someone were to take your device and put another device in its place, there's
If you plug
yeah.
in a rubber ducky, it's going
to act like a rubber ducky. So that's not something we can solve. If someone
NFC more safer than the USB.
Well, but again, if someone's going to go to that amount of trouble, they could make an NFC model,
That's a
right?
different type of attack.
Yeah.
That's not what it is.
Yeah, but it would have an NFC as opposed to this. This is physical contact. NFC would have a different sign-in. You'd have to join it to the device in order to work with it.
Correct.
So innately, it's going to be a little bit more secure.
Well, no, Bluetooth you'd have to join. NFC by default is tap and go. But you still have the same issues you just
But
mentioned.
you'd have to recognize it.
Right, you'd have to recognize it. It would have to have, you could try and issue any malware or any nefarious payload. We can't solve that. What we can solve is if they're trying to use that to mimic your authentication, the previous generated key is going to stop that. But again, if you lay it on your device and someone takes it and duplicates and makes it look just like ours and swaps it, we can't solve that. That's a different risk issue.
The general problem that they're trying to solve is that if services are tied to a password and somebody has your username and password, they can become you, right?
Right.
So if you need another factor authentication, something that you have also, then even if they have your username and password, they can't become you.
Or vice versa. They have something you have, but if they don't have something you know, being your username and password, so either way, you're cutting off that attack vector.
So possibility of a key being copied, make some device and sort of extract information from the key and make a copy that looks like that. Is that a possibility?
Well, that's what we were talking about. If you did that, that's a different risk issue. If someone was, taking and trying to mimic and copy this and make you believe it was your Yubikey and they swapped it out, we can't solve that problem because that's a different risk issue. They would still have to have your username and password, and then if they're going after, say, a malware or an injection into your system, that's a completely different problem that you're dealing with. If they're trying to gain access to your authentication, well, they've still been cut off because they don't have the previous generated key mechanisms that were generated in the key handles and that attestation. So you're still cut them off at that point. But again, if someone is, that's a bigger problem. If someone's taken the time to manufacture and make it look and behave just like a Yubikey, and have taken the time to, to penetrate your facility. Yes, and then it becomes a data protection issue. At that point, what are you doing to protect your data? If you're operating in that world and you're that high of a target, there's other issues involved, and there are ways to combine. Because remember, security is based upon defense in depth, the best security. That based upon your risk assessment and your risk posture determines what are your behavior characteristics. Authentication is just one mechanism that you would have to deal with if you're that high risk of a target. At the end of the day, you'd have to have data protection mechanisms, and at the end of the day, you would need physical security protections. You need bodyguards. Yes, sir.
Off topic, but who do you guys prefer for a password manager company?
Well, we've been working with several over the years. LastPass is probably our number one partner in the password management. And if you use LastPass and you use Android, you're going to love the NFC version of our device because it is tap and go. And the same device will then work in your laptop or your desktop via USB to support your LastPass. We've reached a point, though, that we're a little bit currently disappointed with LastPass because LastPass is not aggressively moving forward to adopt U2F as an emerging standard on the web services side to do that authentication mechanism. So we've reached out recently and are in talks with Keeper, who's the second, the number 2 password management solution in the market. So we're very agnostic. At the end of the day, we allow LastPass, we allow Keeper, we allow you. You want to build a password manager, if you want to use just native, say Linux Pass, you can stand up the UBX cloud and immediately attach that to your pass within Linux and be off and running, being your own relying party.
Yeah, I remember seeing something about working with Google Authenticator as
Well,
well.
we did work with Google Authenticator, but remember Google Authenticator, Google has moved off of Authenticator and moved onto the U2F with the Yubikey. So early on we were working native to the Google Authenticator, but Google has backed away from Authenticator. They don't use Authenticator any longer. They've moved away. All Google, everyone in Google is using the Yubikey and U2F.
Which does Google going with? The one with the Wi-Fi?
No, surprisingly enough, this is the Google key. This is what we call the, nope, Google's specified. These are custom. These are what they call the Sky. This is the security key by Yubikey for Google. You'll notice it's Google Blue. Google specified the color. They sent us the color palette. So if you go look for the security key by Yubikey for Google, or if you go to Google and you do two-step verification, they will actually give you a link to the Amazon web place of where to go buy this key. So this is the Google key. It's limited to U2F only because they weren't interested in all the other functions today. They wanted to get U2F rolled out into their user base. So we do some custom, we do custom keys all the time. This was our Christmas pack this year. So we ran a sale that I believe it was $40. You got 3 keys in red, green, and white, and for Christmas. We run custom colors for organizations. We do custom laser scribing for organizations, but it really kind of comes down to what functionality. The keys that we sell into the market, at minimum, do U2F and HOTP. That's the standards that you saw. Then we have the NEOs, and the NEOs are the full functioning, which includes CCID, but depending upon the form factor determines whether it does NFC or not. So any of the nanos don't support NFC because they can't. There's just not enough real estate in here. Any of those that are the non-nanos, they support everything. And the way you can tell they're NFC is they have the little Wi-Fi indicator on the contact. And while I'm answering questions, I'm going to step over here to my machine and show you real quickly. So in my machine, not that anyone can see it because it's so tiny, I have a nano loaded onto my device. And let's see what screen I'm on here.
Flip that light back off. Normal.
So I have got a nano in my device, and I'm going to do 4 different authentication mechanisms using the same nano device. So one of the ones for sysadmins that we're getting a lot of momentum and penetration for those that are in enterprises and dealing with a Windows backend, Windows Enterprise, is the ability to load PIVs and PGP certs directly into our CCID functionality. So in this example, I'm going to connect to a remote Windows environment. You'll see that it recognizes that I have got a smart card inserted into my device. That is my nano device that's inserted into my USB. So now I don't need a password. We've changed it to a PIN is what it requires. Right now, let me get the right keys, not fat finger it. So now I'm going to make a remote connection into our demo Windows environment, setting up in a lab in Seattle. It verifies on my connection. It's now going to issue my cert, so my PIV is being issued out to the RDP, verifying me against Active Directory. And depending upon how slow the connection will determine how quickly this happens.
So I'm not a security expert, so I just want to ask a dumb question. We
Sure.
use both the Yubikey and the PIN for you to be able to connect?
Correct.
Okay.
Because again, something you know, something you have. So again, I haven't interacted other than entering my PIN because my certificate is loaded at this moment. I don't have to make contact at this moment.
It exposed the cert after.
Yeah. Oh, we've locked it down to, I should have had the guys open this up on the test. So yes, it's locked it to this particular PIV, and you could have multiple PIVs. So there is a depth limit of how many PIVs you could load on the device, but we just preload the PIV, so we generate on the CA in the environment, we generate a cert. No, I'm using my wrong key. All right, so much for that demo.
What certificate authorities do you interact with?
Well, again, that's the environment that gets to choose what CAs they want to interact with. We don't care. Any CA can issue out a PIV for that Windows environment. So you could use the built-in AD CA. You could use any of the third-party CAs that are out there. That we don't care because a PIV is a standardized certificate format. So
Agnostic to it as long
yeah,
as it's a PIV.
as long as it's a PIV that you can import and convert to a PM format. So on import it has to be a PM, and then you can import that PM, and we don't care who you're verifying it against. That's a yeah, PIM. We also have PAM modules, which is different than PIM. So we can also do challenge response, and you can embed that challenge response mechanism directly into the CCID functionality. So here is my Salesforce logon. So here I am being prompted for a password. So if I get my fingers in the right place. So on authentication, it prompts me saying I've got to insert my Yubikey and tap. So I'm going to tap, touch the side of my computer where my Neo is located. Now I'm doing HOTP against the UBX cloud, and I'm now authenticated into my Salesforce account. Now for Gmail, I'm going to connect to my Gmail account. Now I'm going to demonstrate a couple of things on this one. We can also embed static passwords on our device because, again, passwords are still going to be here for a while, whether we like it or not. One of the challenges of passwords, though, is making them complex and making passwords strong. So we can load up to a 32-character randomly generated alphanumeric password embedded into the device. And so I can now release that password from my device and not have to remember that as a user. So in this case, I'm going to be doing two functions here. I'm going to be releasing a password from my device, and then it's going to request my device for the U2F authentication. So I'm going to do what's called a long hold, because on our devices, and I'll show you the interface if you care to see it, we have several slots that users can interact with and configure. We have slot 1 and slot 2 that allow you to load in challenge and response, static passwords into those slots, or HOTP. U2F is built into the device, doesn't use a user slot. So I've got my first slot set up for using HOTP to Salesforce. So my second slot is configured to issue a static password. The difference being is how long I make contact with the device. If I want to release my HOTP string, it's a short tap and go. If I want to release what's stored in my second slot, it's a long press, is what we call it, which means I have to tap the device and hold for 3 seconds or more to release what's stored in slot 2. So in this case, I'm going to tap and hold what's in my second, if I can find my device on the side. Yes, sir.
That sent plain text?
Oh, there it is. Say again?
That sent plain text?
No,
When you
meaning
release your passcode, your static
alphanumeric. And our configurator will allow you to generate, or you can just put in any alphanumeric, complex, or special character, any complex password up to 32 characters.
It's a keyboard.
That
It's
is
a keyboard, so
stored
it's
in
plain text.
the key.
It's a configurator, and I'll show you that in a moment. So we have what's called the personalization tool. So if you're using any of our keys, with the exception of the U2F key from Google, you would want to download our personalization tool, as well as what we call our Neo Manager.
It's stored in the key.
It's stored in the key. So the first thing you saw me do was a long tap, and it released my password. So that was my password to Google. Now Google is telling me, okay, well now you need to do a U2F verification of your key. So for that, again, I do a short tap on my key. I keep missing the slot. And now I'm in. If you are a Google user, and when you get one of our keys, it's as simple as going into your two-step verification. This is where you enable two-step verification. You'll see here it has a security key tab. And in the security key is where it allows you to manage your security keys. Google currently allows you to register up to 10 keys per an account. So you'll see I have 2 keys registered into my account. So in the event I break or lose my 1 key, I've already got a backup to whoever was asking that question earlier that'll allow me access into my device. Now if I don't have a second key, I can use the secondary mechanism that I chose in Google, which is SMS, to verify me, let me back into my account so I can come in here and register a new key.
What if you use Outlook to access the Google?
Then you have to, inside Google, you have trusted applications. So
You cannot use the
no, Microsoft is like Apple. We are in discussions with Microsoft to help them solve this problem, but Microsoft is sometimes the last to the game. So we are in those discussions with Microsoft. Like I said, we're hoping this year they're going to be a little bit more aggressive because they took the chair of the FIDO U2F board as of January. Everyone's a little worried why they wanted into the FIDO initiative because they haven't been doing anything to roll out U2F in any of their solutions. So everyone is watching closely and asking Microsoft the question, what are you doing? Why did you want in this if you haven't done anything to support U2F? And why did you take the chair position? Because as with a lot of these standards base, it's a rotating chairmanship, right? Last year Google had the chair. Year before we held the chair because we were the ones that started the whole U2F initiative. But everyone that's a member of U2F gets to submit and have a chance at sitting in the chair position of that committee. It's January, Microsoft's turn is at the chair. We're hoping by that, like I said, that's going to bring some pressure from the industry. Again, that's going to come from this part of the world. It's going to be users and the consumers of those products beating up on these providers and saying, when are you going to do something to take the security of our environment and our passwords seriously?
In spite of having disbanded the whole trusting computing division.
Yes. But pressure in sales. Now we're in talks with 2 of Microsoft's largest enterprise consumers today. And we're moving forward with implementing. They're going to have a tremendous impact on Microsoft because when their 2 largest customers come and say, we've standardized on the Yubikey, you either get this solved or we can start looking for another solution. Money talks, right?
Application-specific password solves that problem.
Yes, if you're using, but it doesn't solve the U2F. It provides a workaround where you get your QR scan code, you get your generated key, you then trust that application. And so I do that. For example, I use Thunderbird. So I have to have an app-specific password for my Thunderbird to access my Gmail. But when I come in via the web interface into my Gmail, it prompts me.
It's pretty cool because you have to access using that app-specific password using the application inside of that environment. So if it sees any of those variables change with that application-specific password, it won't work. So if somebody were to intercept it, they would have to also provide that environment.
So the 2 applications I mentioned, if you have anything besides the Sky, which is the U2F specific, is you would want to go out to our website and download the Neo Manager and the personalization tool. The Neo Manager is what allows me to specify what operating mode I want to set for this key. So you'll see here I've got all 3 modes turned on this Neo device. I've got OTP, U2F, and CCID. When I turn on CCID, these are my available CCID applications embedded in the device.
So this works on the Neo today?
This works on the Neo today. Anything on 2.2 or above. So if you're not 2.2 or above, then no, it does not work. So you'll see here that I'm on 3.3. The new ones that are hitting out on the fulfillment channels are all going to be 4.0. So once I have set my mode, this is all this is for, is setting the operating mode of the Neo device. Because again, some organizations want to restrict. If they're not using CCID, they don't want to turn that on. They want to restrict it to maybe just OTP and U2F, or vice versa. They may only want to be operating in CCID only. So this allows you to specify and control what mode the Neo device is operating in.
Can the firmware be updated?
Again, we talked about that earlier, not today. Again, that was originally we got hamstrung by NXP because the chips are NXP and NXP controls that license. And it was about a $25,000 entry price. Early on, they allowed our developers to have free access to the firmware development kit. Then they realized how many users were signing up for it, and then they pulled the carpet out from under us and our dev community and started requiring they register and pay the SDK kits. Once you've got the Neo Manager, The personalization tool is where you configure the different functions within the device, with the exception of U2F. There's no configuration on U2F because, again, the key is being minted, the relying party is storing it, that's baked into the device. So there is no configuration option that you can specify under U2F. But you can see that you can do the Yubico OTP mode, the HOTP mode, static password. So that's where I would go create my static password and choose what slot. So for example, just to give you an idea what that looks like, if I wanted to create a static password, this is where I can choose what slot do I want to put that static password in. I've got several parameters that I can configure, including having it generate a randomly generated complex password. So we give you full control of how do you want to configure this environment.
Questions. Are you in touch with any hardware manufacturer to integrate these in computers?
Yes, okay, I'm going to discuss a couple of early things this year. So again, you didn't hear it here because I'll deny it. But there's a couple of things that are going to be happening this year. One is we're looking at so for devices that are not NFC or don't have USB, Bluetooth will be the avenue. The specs are still being worked out because we're trying to look at which is going to give us the widest penetration. And then the other thing to keep your eyes open is look in February, we'll be announcing the first US Yubikey contest that will be opening up to any individual or any team that wants to compete and develop for a U2F solution. And then prizes will be all expense paid trip to either Black Hat DEF CON or a case of Chromebooks. The prizes are still being worked out by marketing. That's why I don't know what the prizes are yet. But it has been official by the company that we are doing our second Yubikey contest in the US. We did a Yubikey contest 4 years ago in Europe. We ended up hiring one of the engineers that won that contest, and then LastPass hired the other one that won our Yubikey contest in Europe. So we're opening up to the US. So any developers, any sysadmins that want to develop a cool U2F solution, check our webpage and our newsletter in February is when we'll be announcing the terms of the contest, and please enter into the contest. We welcome that input. We're getting some of the coolest solutions are coming back from our user community, are coming back with some of the greatest solutions for it.
Do you know if Lux supports U2F yet?
I don't know. So any questions? Yes, sir.
If you have a network that say is not connected to the internet or anything, it's just standalone, is it possible to use this?
Sure is. Because again, you can the code's open source to go get our UBX code, and you can have your own authentication, be your own relying party at no cost other than the cost of a a VM instance or a server.
It's a more like security type question. Say if somebody bought one of these from Amazon and a non-genuine Yubikey got delivered to them, and then it wasn't working, but it did have something else in it. Is there a way to authenticate it before
Yes,
it
on our
gets-
website, you'll see that we have a mechanism that allows you to go verify your Yubikey against our environment, and we'll verify if it's a genuine Yubikey.
in a kind of sandbox type
Yes.
setting?
Is it like a mic or something that you're using?
I'm sorry?
Is it a mic?
A mic.
Manufacturer installed certificate?
We have the attestation certificates. So we're able to verify what were the attestation certificates we released within that range. And then you'll notice that we serialize. So you can also serialize, but we allow you to overwrite that serial. So the serial becomes unreliable, and we stop track with the attestation. And we stopped tracking serials. So up until a year ago, we had a database, we tracked serials. And we started doing that as a benefit to the market, because we had police departments and stuff calling us up and say, hey, somebody turned in, we found this Yubikey, we'd like to return it to its owner. And so we'd go look in the database, find the serial, and contact the owner. And then we took a second look at that. Says, yeah, that's probably not the best. When it's police departments that keep calling us, something's a little fishy about this. So we quit tracking serial numbers because now that we're not in the middle of that. We're able to say, now we don't track it. We don't disclose for our users. We protect the privacy and anonymity of our users. So if you lose your Yubikey, if it's found, there's nothing we can do for you. All right. Well, with that, I appreciate.
Business model too. I mean, if you, why give it back to the user? You just buy another.
Right. But like I said, we had to do a second thought because first there was the sysadmins that were building the database said this would be very cool, and then we all started really looking at this and no, that's not as cool as you think. When we started, like I said, getting calls from police departments, and it was on about the 5th time we got a call from a police department saying it's interesting how it's the police department that keeps finding these keys. So we stopped tracking, and now we say nothing we can tell you, throw it away or. Yes, sir.
Why not biometric solution? Why not even linking with biometric?
Well, biometric adds both complexity and cost to the solution. Now, you could tie this in. There's nothing preventing you from tying this into another factor. You can layer factors. So if an organization wanted to require user presence and a Yubikey and then a biometric verification, there's nothing restricting an organization. We're not going to deploy the biometrics because of the challenges, cost, and complexity of managing biometrics. And as much as there is debate, there are exploits against biometric. The still super glue, the gummy bear, the rubberized gummy bear attacks still are valid attacks depending upon how they've implemented it. And biometrics can be unreliable depending upon the environment they're in. We had a lot of users, for an example. Well, we are operating.
Did a really good. Mythbusters did a really good episode on it.
Tested, which is Adam's podcast. Did it and with silicone that you could buy
over the counter.
Yeah. Because several years, back when I was an undergrad, there was the tech writing class, and they gave us some literature on test results of various biometrics, and the best one by far was a hand geometry scanner.
Yeah.
You just lined your fingers up with some pins, and it took a picture of the top and the side, and it was better than a retina scanner.
But it's hard to get that into a small USB that's easy to fit into your pocket to carry around with you.
You do that with a phone camera.
Right. And I spent years supporting the intelligence services. So my background is I spent a lot of years in DoD supporting intelligence services. And during Afghanistan, we had a real problem with biometrics. And it wasn't a failure of the systems being compromised. It was a failure of the physical devices. Because operating in a sandy environment, they were abrading the readers. So in about 3 weeks' time, when they were trying to get access out at a very hostile location to get sensitive information sent back, and they would stick in their biometric device, and it had been abraded after 2 weeks of rubbing their finger with sand, and they could no longer get access to their system. It's like, okay, we have a problem, Houston, because now we've got assets downrange that have critical information, and they can't get onto their system because their biometric reader is no longer working, and we can't send them down to Ahmed Souk to go buy another one because it's not available. So there again, it's not only a security issue, there's also just some logistic problems and challenges with biometric. So that's why we looked at that, and it got immediately kind of discounted that that's not our path. Any questions? No questions, then I'm ready to hand out keys. Who would like some keys?